Good morning and welcome back to another episode from the Tech Espresso series. My name is Rashmita and I'm the event planner for Microsoft Reactor India. I'm here today joined by a very own host, Dixit. And before I hand over the floor to him, uh, I would request you all to read our code of conduct. We are all here to learn together. So please be respectful of other people's views, understanding of differences, being kind and considerate in the way you engage. The chat section is open throughout, and we do encourage you all to participate. Dikshit will answer all your questions during the session, so please feel free to drop all your questions in the chat section. With this, thank you all. Enjoy the session. Over to you, Dikshit.
Hey, good morning, Rashmita. Thank you so much. Uh, Good morning, everyone. Just probably before starting the session, just a brief about me. Uh, Working in Microsoft for the last couple of years, been in the working couple of teams now, the part of Azure engineering team as a part of customer engineers, handling startups, unicorn accounts on a day-to-day basis. So today's we are going to cover regarding the networking concept that we have in the AKS, and we'll go through each one of it with detailing part, uh, even from the portal perspective also. So that's a brief about me. So Rashmita, are we good to start it, or shall we wait for a couple of minutes?
Sure, we can bring your presentation, Dikshit. If you're ready, I can just add your presentation to the string.
Yeah, okay.
Okay. Okay, let me bring your presentation. Yep, we are ready to go.
Uh, we can start, right?
Yes, we can. Sure.
Great. Thanks, Rashmita. So again, good morning, everyone. Thanks for joining. So today we are going to cover regarding the AKS networking overview, the various plugins that we have available in the AKS, and various uh, the configurations available as a part of exposing those internal services to the outside world, so that the end users will able to consume it, or also certain couple of things in which we are not able to expose those services, and keeping those services in a private mode, keeping only within the clusters. So all those things we are going to cover, and also we will walk through from the portals side of the things as well. So let us start, and please feel free to stop me if you have any questions in between. So moving on, uh, so we have the slide deck, but probably let's go through the more interactive sessions with the clear understanding at how things work from the backend perspective, so that we are quite clear that when we are working or when we are thinking from any particular networking concepts in the AKS, what exactly happening from the backend perspective. Now, uh, let's say when we deploy the AKS cluster, eventually the AKS clusters is being deployed into the particular VNet, and to be precisely say, it is being deployed into a particular subnet. So when we say, uh, I can say this is VNet, under that we have subnet, and under that we have the you can say the AKS cluster deployed into that particular subnet. Now that particular AKS cluster, just hypothetically say, has let's say two nodes as of now. This is one node one, this is node 2. Now what we have defined as of now, we have a VNet. Under that particular VNet we have a subnet. Under that particular subnet, the AKS cluster is being deployed, and under that AKS clusters we have two nodes, node 1 and node 2. And those particular nodes, we have the pods. So obviously we are not going into the basics of the AKS, what are pods, what are nodes, and the containers. I hope everyone is aware of those things. But uh, me and Rashmita, after this particular session, will share those links if somebody is not aware of the basic concepts of the AKS cluster as well. So as of now, we have node 1 and node 2. Let's say on these particular nodes, we have a pod 1, P1, and on this particular thing, we have a pod P2. Now under these pods, obviously we know that the containers are running under the pods. So now let's say a pod P1 running on a node 1 want to communicate to a pod 2 running on a node 2. No, now to communicate, obviously there should be some mechanism, there should be some way that I should be able to reach to a certain pod running on this similar node or running on a different node. So in this particular scenario, to reach or to have the communication between the pods or the entity should have certain IP address to which I can be able to reach it out. So for example, I can say this particular pod have IP1, this particulars have IP2, and obviously the nodes also have certain IP addresses. Okay. Now going with the AKS plugins that are available, we are going to discuss in a while. But as of now, what we have discussed, we have a VNet, under VNet a subnet, under subnet or in a subnet we have deployed the AKS cluster. In the AKS clusters, we have two nodes. On those particular nodes, the pods are running, and for each particular pods we have the IP address, and for a node we also have the IP address. Now the point to note here is that the pod, whatever IP that has been assigned or that have been assigned to the pod, should be unique, should be different, and should not overlap with any of the CIDR range that we have defined for the subnet or the VNet. Any questions as of now from anybody? If this concept is clear, then probably we can go to the network plugins, the other networking concepts of the AKS cluster. But this is the basic concept. How that particular how these concepts fall into the AKS concepts of the various plugins, network plugins that are available, we are going to discuss just probably after this. But any questions until this particular point?
We don't have any question, Dixit, so you can move forward.
Sure, thank you. So let me wrap this. Now what we are going to discuss regarding the the networking concepts in the AKS as a part of various plugins available. So there are two plugins available. One is the KubeNet and the other is the Azure CNI. So let's discuss first about the KubeNet part. Now again, coming to the same concepts. So we have a VNet, under that VNet a subnet, under that subnet we have deployed the AKS clusters, and let's say we have two nodes. Under that nodes we have pods running. Okay. Now under kubenet, so in the initial discussion, we discuss about, obviously VNet has some address range, the CIDR range that has, and even the subnet is uh, the smaller, the subset of the VNet that we have. Now under kubenet, the nodes, the worker nodes are getting the real IP address. Please note my words. The worker nodes are getting the real IP address from this particular subnet range. But in the case of kubenet, the pods that we have in this particular pictorial representation, we are showing these four pods. these 4 pods are not getting the IP address range from the subnet range. So the pods will get their pods CIDR range completely different from the subnet range, and it will not overlap with any of the range that we are using. That is the most important part. So by doing this, what we are saying, that we will be able to spin the pods, and pods are using the IP address range which are different from the subnet range or the VNet range that we have spin up. But the worker nodes on which pods are being deployed are getting the IP from the subnet range. Now, in the earlier discussion, we discussed that now let's say if we want to communicate between the various pods running on a different nodes or various pods running on the same nodes, how to communicate it, because the pods the IP of the pods are not the real IPs. These are the pods. CIDR range is completely different from the VNet range that we have defined, or completely different from the subnet range that we have defined. So these are not the real IPs. So in the kubenet, what we have is another concept which is called route table. So in this particular route table, we will define, for let's say this particular pod P1, we will define some IP range, some IP from the pod CIDR range. It will get one IP allocated to this particular P1. Same thing goes for the P2. From the pod CIDR range, the pod P2 will get a certain IP. So what we are defining a route table in which we are doing a mapping, that this particular pod maps to this particular IP. The another pod maps to this particular IP. So if we want to communicate, the route table will come into the picture, and you will be able to communicate to the between various pods running on the same nodes or running on the different nodes in the same cluster. Now, the other couple of points when we need to discuss is the pod CIDR range. What we are defining here, it's need to be unique only on this particular Kubernetes cluster. So what it means is, for example, if I have a 20 AKS clusters, these pod CIDR range can be same on those 20 AKS clusters, but it needs to be unique on the specific AKS cluster we are running on. Okay. Any doubts till this particular point? Okay. I will take it as a no. Now, if we switch back to the portal, uh, Rashmita, I hope we are able to see the portal screen as well.
Yes, yes, Dixit.
Okay, sure. So we define the kubenet plugin. What we are saying, the pods will get the pod CIDR range different from the subnet and the VNet range, but the nodes are getting the IP address from the subnet and the VNet range. Now, this is the Kubernetes cluster that I have created in the portal. Uh, I have created for the kubenet plugin. If you see, the network type is kubenet. Now, if I click on the networking side, so it is showing the type kubenet, and it is showing the pod CIDR range, this particular range. Now, when we discuss the another uh, plugin, which is called the Azure CNI, you will not be able to see this particular concept, the pod CIDR range. We will going to discuss why, but just remember that as this is the kubenet plugin that we have used while creating this AKS cluster, that is why you are able to see this pod cider range when you create the Azure CNI cluster. The when you create the Kubernetes cluster with the Azure CNI plugin, this particular pod cider range will not come into that particular concepts. Now if you click on the properties, and if I click on the resource group, now this particular, so we are discussing that uh, uh, that under the kubenet, if pods are need to communicate to the another pods, we need to define the route table because these are not the real IPs. So we need to do the mapping that for this particular pod, this is the IP. For this particular pod, this is the IP. For reaching out to that particular, to make the communication to that particular pod, we need to define the route tables. Now this is the route table that we are discussing in that particular concepts. So if I click on this particular route table, it is showing me the as in this particular AKS clusters we have three nodes. So the that particular pod cider range is being divided into three nodes. So it is showing that for first node, this is the IP address range that the first node get. For the second node, this is the IP address range that node second get, and obviously for the third one, and so on and so forth. So the main concept that we have discussed, and the main thing that we need to uh, remember is that in the kubenet, the pods IP will get the pod cider range different from the subnet and the vnet range, and these are not real IPs. Now if we want to communicate, how to communicate, we need to define the route tables. In the route tables, we will do the mapping that for this particular pod, this is the IP. For the second pod, this is the IP. So one of the factors that will come into the kubenet is obviously, as we are defining the route table, there is a extra hop that will come into the picture while communicating from one particular pod to the another pod. It can be on the same node, it can be on the same node, it can be on the different node. We'll take a pause. Any doubts in the kubenet plugin? Because the only point we need to remember is the pods are not getting the real IPs, and the pod cider range is different from the subnet and the vnet range. We'll take a pause. Please let me know if you have any questions from anybody.
Dixit, there are few questions. I'll just bring those questions on the screen.
Okay. So who maintains route table? So that will be taken care by the AKS cluster. That is how the managed offering will come into the picture. So from the portal side, let's say, uh, it's a good question. So from the portal side, while creating, so for example, let's say I will create a Kubernetes cluster. I click on the Kubernetes cluster, and I fill all those basic details that I need to fill in. And if I click on the networking side, so it is showing two options, kubenet and Azure CNI. So if I click on kubenet part, it will just giving you the options to fill. But what is the route table and all those mapping will be taken care by the Azure infrastructure itself. It is something like, so while creating the AKS clusters, which one to go for it. So we will discuss those concepts also, but you should be quite clear that while using the kubenet, these are the factors which come into the play. For example, the hop thing, the route table, and while discuss the and using the Azure CNI, these are the factors which will come into the play. But the if the But the answer is that who will manage it? The Azure infrastructure, the managed part will take care of all those offerings. Any more questions from anybody? So Shobit, any pre-request for subnet? So we just need to define that the IP range that we are going to use for the AKS clusters. But just be mindful that for obviously depending upon the scale that you are looking for. So for example, if I'm looking if I'm the e-commerce application and I'm a big player, so I should be aware that the range that I'm defining for creating the AKS cluster into that particular subnet should suffice my future needs. When I say future needs, I can create the AKS clusters starting with only 2 nodes, but probably let's say during sale time or during festive times, I need to scale out my 2 instances to the 10 or 15. So the IP range that we have defined for creating the subnet in the AKS clusters should suffice those particular scale out needs from my business point of view. Shobit, I hope I answer your question. Any doubts, please do ask me again.
Dikshit, you can go back to your presentation while I'll just bring the questions, or I can read out the questions for you.
Okay, okay, sure.
Yeah, so there is another question from Shobhit itself. Do the route in the RT get created automatically?
Yes, the route table will get automatically when you create the AKS clusters, and you will choose the option kubenet plugin. The route table will be created automatically.
Okay, there's another one from Bharat. If we are using NVA, how to use this?
NVA, let me look at it. Bharat, can you please throw some more light on the NBA part?
He has another question, I think, add on to the first question. So, uh,
Okay, that Bharat we can take it probably at the app, because it is going to be a little you can say uh, more into the deep side. So probably once we discuss the basics configurations for everyone, then probably we can go into the deeper side of things.
yeah, no more questions for now, Dikshit.
Sure. So let me run this. Got it. So we have discussed the fundamental of uh, basic networking as of now. So we have started with the VNet, subnet, deploying that AKS cluster into subnet, and then nodes, pods, and the containers running into that particular pods. And after that, we have discussed about the kubenet plugin. Now we are going to discuss about the CNI part, the Azure CNI. Now uh, we'll go with the same concepts. So we have the VNet, we have the subnet. Under that subnet, we will deploy the AKS clusters, and let's say the AKS cluster is having 2 nodes. Uh, this will have this particular nodes has the IP. This particular node has the IP. Under that particular nodes, we have the pods. Now, the major difference from the kubenet to the Azure CNI part is uh, in the Azure CNI, even the pods 1, 2, 3, 4 all will get the real IP address from the subnet range itself. So IP from subnet range that we define. So what we are saying, in the CNI plugin, in the CNI networking plugin, even the pods which are running on the nodes will get the real IP from the subnet range that we have defined for the subnet. So as these are the real IPs, you will be able to reach the pods directly. So there is no route table or there is no extra hop required to reach to a particular pod running on the uh, specific node or running on the AKS clusters, because obviously when we define the subnet, those IPs are reals, and the nodes and the pods will get the IP from those real IP address range. That is why there is no hop required, there is no extra hop, and there is no hop required, and you will be able to reach the pods directly. Now the one of the uh, I can say, uh, I will not say the drawback, but one of the thing that you need to keep in mind while going with the Azure CNI. Obviously, you will have more control that what you are defining in terms of IP that you are using, in terms of subnet range, and in terms of VNet. But obviously, as even in the case in the case of Azure CNI, as uh, the pods are also getting the real IPs from the subnet range, so you need to be uh, uh, plan those IPs in a way that your future needs will be suffice according to your business needs. Because let's say if you define a subnet range, uh, a small subnet range, and those have just a hypothetical example, let's say 100 IPs. So when you deploy pods on the nodes that you have defined on the AKS clusters, so you will be able to obviously pods are getting the real IP in this particular networking plugin, the Azure CNI. So please plan accordingly so that your future needs, in the case of scale out needs, or in the case of uh, uh, the business needs, you will be able to meet those needs if there is a demand to scale out the application that you are running on. Because in this particular case, the pods are also getting the real IPs, which we are not getting in the case of uh, the kubenet. We'll take a pause now. Any questions or any doubts in this particular concepts?
There is one question from Bharat: how to save more IP in regard to employee CNI and root table?
So Bharat, in the case of Azure CNI, the route table will not come into the picture, because in this the pods are getting the real IPs from the subnet range that we are defining. So the route table will not come into the picture. That is why the extra hop that we are getting in the case of kubenet will not come into the picture. But yes, the question that regarding how to save more IPs, that totally depends upon you. So that is why the one of the thing that you need to be quite sure while creating the or while using the Azure CNI plugin is that you need to be quite mindful that these are the IPs that you need required from the business point of view, probably in the due course of time. That is why we said that uh, you need to plan well while using the Azure CNI, because these are the real IPs that you are getting from the subnet. So it can't be a case that you need something more from the scale out perspective, but at that particular time, but at that particular point, you don't have the IP to allocate to the pods and the nodes that you are putting into it.
Actually, there's another one.
Hmm.
How to save more IP in regard to deploy CNI and route table. How to change Docker IP because it always start from 172 range.
So again, the same question that have been asked previously. So the route table will not come into the as a part of Azure CNI plugin. The route table will only come as a part of Kubernetes plugin. So once you uh, create the Kubernetes, or once you use the Kubernetes plugin, the route table will come into the picture because the pods are not getting the real IPs. So we need to define some mapping so that you will be able to reach out to the pod to make the communication. That is why the reason is the route table is being created automatically and the route tables are defined. The route tables are not present in the Azure CNI because the pods, in this particular case, hypothetically, we have defined 4. The pods are also getting the real IP from the subnet range. So if the pods are getting the real IPs, so there is no need to define the mapping that this particular pod maps to this particular IP, because you are anyway getting the real IP from the real subnet range. So the route table will not be created and there will be no extra hop required.
I'm not sure, Dikshit, if your answer to this question, but then there's a follow-up question again from Bharat. How to save more IP in regard to deploy CNI and route table? How to change the Docker IP because it always starts from 172.
But again, same thing we mentioned, right? The route table will only be created during the Kubernetes plugin. It will not be creating when you are use the Azure CNI. And regarding the Docker IP regarding the range, so you can use the other ranges if that particular things, if you are intended to ask that particular questions. But please feel, what I can do, I will also share the email ID after this particular sessions, so you can reach out to me directly over the email, and if there are any further discussions that we need to take it one on one, or let's say further discussions on a deep wide, we can take it one on one. I will share those. I will share my email ID after this session also. Is there any way we can deploy route table in two zones if my case is redundant? No, but if that is then, uh, so Bharat, there is no yes or no answer what you are asking to this. So obviously there need to be have the discussions or the couple of questions before answering this. My request to you is, I will share my email ID, and then if you have any further questions, you can reach out to me over the email and we can discuss thoroughly. But yes, uh, in this particular question, my counter question is, why do you need two redundant AKS clusters? If it is from the DR perspective, then there are other good ways to do it. And obviously when we are doing the when we are taking care of the DR and from the resiliency perspective, for each specific AKS clusters, the route table will be created. So for example, if let's say I'm creating the AKS cluster into the India regions, and for the DR perspective, I'm creating the AKS clusters one into the Europe regions. For two separate AKS clusters, the route tables will be defined for the respective things. But one route table for two AKS clusters is not there. I hope I clarify your question. But yes, there is no yes or no answer what you're asking. It needs a deeper discussions and probably a couple of questions from my side to understand your scenario better. Shall we move on?
Yes, Dikshit.
Sure. So coming back to the slide. So this is the same thing that we have uh, discussed. Just having the uh, probably doing the quick walkthrough that we have discussed in the last 30 or 35 minutes. Again, in the case of kubenet, as you can define that you can see that there is a virtual network, there is a subnet. We have defined the subnet range. From that particular subnet range, the nodes are getting those IPs, but the pods are getting the IPs from the different cider range, the pod cider range. That is completely different from the subnet range in the case of kubenet. Because of that, as the IP which are been assigned to the pods are not getting the real IPs, and that is why you will be able to create uh, the the route tables, and the netting and the extra hop will come into the picture. That we have discussed, that we have looked from the portal also, that when you create the AKS cluster uh, with the kubenet plugin, so you will be able to see the pod cider range. Please be mindful, when you create the AKS cluster with the Azure CNI, this particular thing will not come into the picture, the pod cider range. Again, we have looked this particular concept from the portal itself, that when we are creating the AKS clusters with the uh, kubenet plugin, the root table will come into the existence to define the mapping of the pods IPs. Now, coming to the Azure CNI, again, we have created a VNet. We have created a subnet from that particular VNet range. In this particular, the pods and the nodes both will get their IP address from the subnet range that we have defined. So if you are able to see that 10.240.0.0/16 is the uh, IP range of the subnet, and if you can see that the pods and the node both are getting the IP addresses from this particular subnet range that we have defined. This is in the case of Azure CNI, and this is the again. Uh, Please be mindful, the pod cider range that you have seen in the case of kubenet on the portal will not come into this Azure CNI, and the route table will not be created because these are real IPs, and you will be able to reach out to the pods or communicate to the pods directly. So we have written the no route tables. Better performance because there are no route tables, there are no hops. So obviously you will be able to reach out to the pods directly. Hence the better performance. So this is the thing I'm talking about. In the case of uh, uh, Azure CNI network plugin, the pod cider range will not be there. It will only have the service cider range that we are going to discuss in a while. But the pod cider range will not come into while creating uh, the Azure CNI plugin for creating the AKS clusters. So when to use kubenet and when to use CNI. So obviously when you need direct access to the pods, you can go with the Azure CNI. When the uh, obviously when the performance is of the utmost priority, you can also. So as of now, there is no I can say benchmark numbers that we have, but yes, in the case of when you are only concerned about the the performance, and you don't want to have the route tables and the extra hop, obviously you can go for the Azure CNI. And the other uh, couple of scenarios, when you go for the Azure CNI, when you want to go with the first hand party or the first party services of the Azure, for example, the concept like Azure network policies or the on the window nodes, or the concept of virtual nodes, those are not available as a part of kubenet plugin, but those are available as a part of Azure CNI plugin. uh, any questions till this particular point? If we have understood this, I believe uh, we we are uh, quite good with the network plugin, because these are the major building blocks of the networking concepts of the AKS clusters.
Dixit,
Any
we have
questions?
two questions. I'll just bring the question for you.
Okay.
Will communication be slower in case of Kubernetes because of the extra hop?
Yes, Ranjit. So if I will so let me rephrase it. It will not be slower from the user's perspective, or let's say, but if you are comparing Kubernetes with the Azure CNI, yes, there will be a some difference, but you will not be able to figure it out that it is slower. But in terms of comparison, if you are making with the Azure CNI and the Kubernetes, obviously, as there is a extra hop, so there will be a some you can say some lag in comparison to the Azure CNI.
Here's another question from Bharat.
Yes. So Bharat, in the Terraform scripts, obviously, you will be able to use any of the uh, you can say the network plugin that you will be able to use. So even both the network plugins are available through the Terraform as well, the CNI and even the Kubernetes. I believe there are lot many samples available over the internet, and even in the case of Azure samples repo also for the Terraform script. And even if I remembered correctly, there is a tool also, Bharat. For example, it will uh, just going out of context, but let me answer this. There's a tool also from the Azure that, let's say, as a user, I need to define, I'm creating the AKS clusters. So I will say I need to define, I'm going with the, in your case, let's say I will define Azure CNI node 3. These are the IP addresses range. These are the things that we need to perform. WAF, application gateway. So when you define all those things, what you need from the AKS clusters, it will automatically give you the Terraform scripts or the Bicep templates or the ARM templates. So there is already a tool available. So you don't need to create these ARM, Bicep, or Terraform scripts on your own. You just need to define that what you need in the AKS clusters, and on the basis of your inputs, the scripts, the code will be available to you. So there is a tool available. You can probably search on the internet and you will be able to have it. If I'm
Uh,
Rashmi, sorry, if I remembered correctly, the tool name is AKS construction, something like that. Just probably have a Bing search and you will be able to have it. AKS construction.
Dikshit, if you have some share links or some repos to share, you can share it with me so that I can, share it with
Yeah,
everybody.
definitely. That will be really helpful, especially the AKS construction that Bharat had just asked. Uh, so do we need to share it right now, or we can share it after this call, right?
Yeah, yeah,
Rashmita?
yeah. We can always. And for the folks, I mean, if you have any follow-up question post this session, you can always reach out to Dikshit. His Twitter handle is already there, uploaded on the meetup page. So you can please feel free to, contact him and ask him regarding today's session or anything else.
Or let me try that if I get it. Yes. So Bharat, this is the tool I'm talking about. I'm putting it in the chat window. So just you need to give your inputs. Based on your inputs, the scripts will be available at the downside of the tool. Shall we move on? I believe there is a quite good number of
Y-
questions, but we need to cover couple of things more.
Yes, yes,
Yeah,
yes, sure.
sure, sure. So moving on. Okay, so we have discussed the basic fundamentals, starting with VNet, subnet, IP of nodes, IP of pods, and then based on these, we have discussed about the Kubernetes plugin, and we have discussed the Azure CNI plugin. So until this point, we have discussed these things. Now coming to the other concepts that we have from the networking point of view is, uh, uh, so for example, let's say I have a pod, 3 pods running, and obviously these have certain uh, IP, either from the Kubernetes plugin or either from the Azure CNI plugin, depending upon which plugin you have choose while creating the AKS clusters. Now, if I need to, so before this, we have a concept which is called service. So even this service will have the IP. Now, while choosing to communicate, so on the same lines, let's say we have another service and we have pods. Even these pods have their IP address, and this service has IP address. Now, with uh, the already available install components of the Kubernetes, for example, kubeproxy and the kubelet, when you try to communicate, uh, when you try to communicate to these pods, let's say these are P1, P2, P3, and P4, P5, P6. Now, when you're trying to communicate from P1, P2 to P3, or to 4, 5, and 6, they will make this particular service will expose these pods as a part of one group, and this particular service will communicate to the to this particular IP of the service. Now, the point to note here is this particular IP of the service, this IP of the service, and this IP of the another service are static. And we all know that pods may get die at any particular point of time. So the IP keep on changing, but obviously from the Kubernetes perspective, it keep on spinning the same number of pods that we have defined. So, but this particular IP, the IP of the service, the logical grouping of the pods, will get the static IP. So if you are able to communicate within the cluster, please mind my words. We are discussing about if we are going to communicate within the cluster, not outside the clusters. This is how the communication will flow, and we called it as the cluster IP or the service IP. It is within the cluster only, not outside the cluster. So this is one concept. uh, Now, coming to the another, let's say, now let's say I want to, I have the pods. Those pods are being grouped as a part of service. Now I want to expose those particular service to the external world. Now, what are the various ways to do it? So for example, again, let's say I have pods, uh, I have service. This is P1, P2, P3. This is service. I have nodes. This is node 1, and this is node 2. Okay, now what we are depicting is It can be on the same node or it can be on a different nodes. So there is no difference in it. And also, please remember that the kubenet and the Azure CNI concept, the network concept that we have discussed, which are the building blocks of the AKS clusters, is only applicable till this particular point. When I say till this particular point, how the pods will make the communication and how the IPs will get assigned to the pods. But after that, after the service level, whether you choose Azure CNI, whether you choose kubenet, it will not make any difference. Now let's say uh, I want to expose, or I want to have the public connectivity, uh, so that these services will be, the user will able to access this particular service. So I will say Azure load balancer, Azure load balancer, which is the layer 4. So what it will say, so obviously Azure load balancer, as we are saying that it is a load, it's a layer 4. So it can understand TCP, it can understand UDP, but it will not understand anything uh, from the, let's say, URL path based routing, from the uh, HTTP request, uh, from the SSL offloading. So it will not do all those activities. Now when we have those nodes, so obviously these nodes also have certain IPs. We have discussed in the beginning. Now what it will do, so we have the kube proxy as a part of uh, Kubernetes fundamentals. So when we have the Azure load balancer with the backend pools of the Azure load balancer, with the backend pools of the Azure load balancer, it will connect to these nodes. So as a in the backend pool of Azure load balancer, you will define these nodes. Whatever in this particular pictorial representation, we are showing two nodes. So in the backend pool, there will be two nodes from the AKS cluster, and it will able to reach out to this particular nodes by the IP they are having. And under that, we have the kube proxy, which is installed by default as a part of Kubernetes installations. You are not doing anything, you are not managing anything. So by the with the help of, when the request comes, the Azure load balancer will go to the nodes that we have, and the kube proxy will take those, and the queue proxy will take that particular request and will go to the specific service. In this particular representation, we are only showing one service. In the same thing, in the same way, we can have many services in the same AKS clusters. So this is how the Azure load balancer will come into the picture to expose services outside of the AKS clusters. Now as this is layer 4, if you want more, you can say, uh, if you want SSL offloading, you need to route request based on uh, the the routing rules you have defined. So you can go for the layer 7. So the same concepts will come into the picture. The only difference is, for example, in the case of layer 7, the common that we have is Nginx and the application gateway. So in the case of Nginx, so we are discussing Nginx and the application gateway because these are the most widely used, but there are lot many. But so for example, in the case of Nginx, even the Nginx will be deployed. Let me rub it again, then probably you will have more clarity. Hmm. We have pods, we have service, P1, P2, P3, we have nodes, node 1, node 2. Okay, now when, let's say, we have the Azure load balancer. Okay, this has the IP, this has the IP. Now when we talked about Nginx, so on the same way, the Nginx will also be deployed as a pod onto the AKS clusters. So it obviously for maintaining the HA, for maintaining the high availability, the Nginx will also be deployed as a multiple nodes into the AKS clusters. So you can write ng, and on the same way, it will also have the service for it to make the logical grouping of the Nginx pods deployed on the AKS cluster. Now again, the same concept will fall into the picture. As we are saying, the service will have the IP, and obviously the pods will also have the IPs. But the communication that we are doing is from the Azure load balancer to the backend pools. Now will be the node 1 and node 2. Under the node 1 and node 2, we have the pod, so it will reach the service of the Nginx, and then from there it will take the request depending upon what service what request arrives, and it will route that particular request to the respective services that we are running in the AKS clusters. In this pictorial representation, we are only showing one service. I keep on saying there can be a multiple service running into the same AKS clusters. So the workflow would be, as your user make a request to the Azure load balancer, at the backend pool we have the nodes defined. In this, but in this pictorial we are saying two nodes. It will go to the one node. From there on, Nginx pods, from the Nginx pods to the Nginx service. Then service will pick that particular request, and depending upon the request it has arrived, it will route that particular request to the various services running in the AKS clusters. Any doubts till this particular points? We have discussed the communication within the cluster, communication to the outside world with the L4 Azure load balancer, communication to the outside world with the help of Azure load balancer, as well as with the combination of Nginx as a ingress controller. Why we are saying ingress controller? Ingress because the the pods or the service of the Nginx will take that particular request, and that particular request will be routed by that particular by the Nginx service, or uh, uh, or by the Nginx pods uh, to the various other services running on the AKS clusters. Per technically, to correctly put it in the technical format, the Nginx service will take that particular request and route that particular request to the different services running on the AKS cluster. That is why we are saying Nginx as the ingress controller. The word as ingress controller. We'll take a pause. Any questions from anybody? Any doubts? Shall we move on to the last concept that we have?
Dixit, one question from Shobhit.
Mhm.
Difference between NG, NIXIC and public LB?
So Shobit, again the same thing. The Azure load balancer is the layer 4 load balancer. When we talked about the Nginx, it is the layer 7 the load balancer. So for example, the concepts like SSL offloading, path based routing, you will not be able to achieve those using the L4 load balancer. You will need L7 load balancer there. So that is how the difference is.
Next question from Bharat.
How to troubleshoot if traffic is coming to load balancer post that it is dropping? So Bharat, I hope you have able you have seen the diagnose and solve problem blade in the Azure portal itself. So in that particular blade, diagnose and solve problems, so you will be able to figure it out that if something is dropping, or if something is able to reach at the AKS cluster, or something is dropping at the pod side also. And also I'm sure uh, you are using the AKS clusters, so you can also go for the Azure Container Insights. So it will also give you a detailed walkthrough of that, if there is any pod, if there is any particular memory, CPU, or if there is any particular drop in the request. So all those details you will be able to see in the Azure Container Insights also. But yes, starts with the diagnose and solve problem based in the AKS cluster itself. Okay, let me move on to the
Here's another
last
one.
one. Okay. No, it's the same one, right? This one we have discussed, Rashmita, I believe.
Okay, so if there's another one, I think probably
Is Nginx
from
free with respect to the? So I'm not sure about the Nginx part, but yes, obviously for the application gateway as the Nginx controller, so we do have certain charges for it, but not sure from the Nginx perspective.
we have another one.
Container Insights is free, but it is very minimal charges. But Bharat, start with the diagnose and solve problem. I believe in that particular blade, uh, we have exposed good amount of information from the AKS cluster perspective that what is happening at the under the hood. So if you are not able to make it anything uh, from the blade itself, diagnose and solve problem, uh, then probably go with the container insights. But but if we are spinning the AKS clusters, and obviously from the uh, troubleshooting perspective and what is happening at every level of it, the container insights is a very good tool, and customer across the globes are using it. So obviously there is a way to look at things, that what is happening, even if something is not even if everything is working right for you, even then you need all those tools, because you need to have full control at what is happening at what level. If something goes for a toss probably in the near future, then you will always in a position to figure it out at what exact logs I need to dig it out to make the things work again with seamless operation. So Rashmita, I believe we are on time. So probably the last one is I can probably cover it here only, is the application gateway as ingress controller. I believe somebody has already asked it. So the only difference between the application gateway as the ingress controller is that uh, the communications are directly in the case of Nginx, we have discussed that uh, so there are multiple pods of the Nginx that we have used as the ingress controller. But in the case of application gateway, there will be only a one pod deployed, irrespective of the number of pods. And by any chance, if that particular pod dies, no big deal. Kubernetes cluster will redeploy it. And in the case of application gateway as the ingress controller, the communication is not through the services. The application gateway as an ingress controller will make the communication directly to the pods. So that is the difference, major difference between the Nginx and the application gateway as the ingress controller. I will share that particular documentation. But yes, that is all from today's sessions. But yes, uh, uh, after this sessions, we'll share the email ID as well. So if there are any detailed discussions anybody wants to have it, you can reach out to me over the email, or Rashmita already mentioned that there is already a Twitter handle share, so you can probably reach out on the Twitter handle as well. But yes, that is all from my side for the today's sessions.
Thank you so much, Dixit, and thank you everybody for joining us today. Yeah, like Dixit said already, Dixit's social handle is already added. So please feel free to reach out to him if you have any further questions. Thank you and have a great day, all of you. Bye.
Thanks everyone. Thanks Rashmita. Thank you so much.